Alright. Hi and Assalamualaikum. My name is Muhammad Ikhwan. So me and my team members, Syahirul Khalik, Saidatul Hanida, and Iza Atira, we are going to present our group project about flight ticket price prediction. So we'll be explaining about the introduction. Okay, so now predicting flight ticket prices has become a beneficial aspect, particularly for travelers, to necessitate their commuting systems. Behind the intricate task for forecasting, there are several variables and techniques we need to encounter in order to analyze data, uncover patterns, and identify potential predictors that influence the flight ticket prices. Therefore, we will employ the SEMA methodology with the aim to help travelers getting the best ticket prices. Okay, so our source of data obtained from Kaggle.com, which originate from IsMyTrip website. It contains about 300,261 flight booking observations collected for 50 days from 11th March to 31st March 2022. So the data set comprises of categorical and numerical variables of airline, data, flight code, source, destination, and etc., which we will further explain in the next slides. So as you can see in the table shown, there are about 13 variables that we have been used following their level and descriptions. So throughout this process, the variables have been explored and pre-processed before we fit into the models. These are the SEMA process that I have mentioned before. We start first by sampling the data from its raw structure. Then we will explore the trends and patterns of the data. We will pre-process the data in the modifying stage. And next, we develop predictive model by splitting into train and test data. And the final stage is to evaluate the performance of the model in the assess phase. In the sample stage, we have conducted random sampling and reduced the dimension of the data set into 60,052 observations. The input source, as you can see in the figures, is named with flight_new2 and is stored in the library SAS user. Okay, so next we will reclassify the role and level of the variables. As for instance, the column role for price, the label initially from input we change to target. The timestamp, the time ID is changed for the role. Okay, so next.
So for Explore part, we did few analyses. First one is the univariate analysis in which we try to see the attributes in the form of graph. So for via attribute, we actually reject this column due to the unity result. And for price attribute, we can see that the distribution is rightly skewed. And then we also did bivariate analysis. So these are the graph that we form in the form of box plot. Next part is we actually did association rule mining and as well as sequence analysis. These analyses, we can see that the objective for association rule is to find co-occurrence pattern on purchasing behavior, while for sequence analysis, we actually want to find the order or sequence of event. So the example that we can relate on our data set is for association rule, when customer choose flight A, they are likely to choose flight B next. For sequence analysis, so say that if the customer choose flight A now, they might choose same flight or similar flight with similar service next time. So these are the comparison of the properties we set for association rule versus sequence analysis. The next part is the variable roles in which we actually set the transaction ID as ID, timestamp as sequence, and we exploit all the nominal variables as target, and we observe when we set the airline as a target, we can see there are interesting patterns to be explored using these two analyses. For the key matrices, we use three main key matrices, which is support, confidence, and pseudo-leaf. For the support, we can see that how common the rule appears in the output. And then for confident, is the likelihood for the right-hand side rule to happen when left-hand side happens. And it's actually measure the rule predictions ability. And then for pseudo-leaf is the measure of how often the rule occurs in the data set than it would if the items were statistically independent. So if the result we see is leaf more than one, you can see that it's having a positive relationship. And then this is the sample of the result. So you can see on the left side, this is the statistics plot. On the x-axis is the confidence percentage. On the y-axis is the support percentage. The more high and the more right it goes, so the higher the percentage number. On the right side is the output result. This is the example that we can see from sequence analysis in which say that the Vistara customer choosing Vistara now, so they might choose Vistara later or they might choose Air India later. You can see on the third row. And then on the other hand, if this customer is currently using Air India, they might choose Vistara later. It actually depends on if the airline is offering the same service. So the customer would just maybe be loyal or just choose another airline that offers the same service.
Okay, the third stage of the SEMA methodology is the modified stage. So in the previous stage, we found that there are missing values in the duration variable. Since the missing values are missing completely at random, the imputation method will be the best method to handle the missing value. So in our case, we use mean imputation. Then we did transformation for price variable, which is the target variable, using log 10 information. And all the variables for modeling were assigned to 4 bins, and section ID, timestamp, and VIA will be rejected due to not being used in modeling purposes. The next part will be modeling part. First, we will split the data into 75% train and 25% testing. The first model will be a decision tree model. The decision tree model is a supervised learning technique used for classification and regression tasks. So in this project, we will be using regression tasks since our target is to predict the flight ticket price. So the decision tree is developed based on 6 maximum depth and 2 maximum branches in each split. So the variable importance, we can see from the figures, the variable importance for the decision tree shows that class is the most important variable and numCode is the least important variable. The second model is regression model. In this model, we use forward selection model to build this model by adding predicting features at a time. So the final feature selection are shown as in the slide. So by doing this, it can possibly help to reduce overfitting. So it shows that R square for this model is 0.8836, which indicates that 88.36% of total variation in the flight ticket price is explained by all the 7 features, while the others 11.64% is explained by the other factors. The next model is the gradient boosting model. Similar like decision tree model, it also shows that the class variable is the most important variable and 2 is the least important variable. The next analysis is time series analysis. So this analysis is conducted to assess similarity and consistency of pricing based on 2 aspects using time series similarity. The first aspect is pricing based on flight services, which involve type of airlines and class offered as cross ID. The second involves pricing based on flight routes, including both from and to column as cross ID. Price column would be the target of both analysis. Similarity measurement used is mean squared deviation, a more common approach for regression analysis to penalize error for outliers. The data was also normalized but does not have any scaling.
All right, so for the performance of the model, the performance of train test set were mainly assessed via 2 different errors, which are the ASE and MSE. So overall, there's no actually significant differences between the train and test error, indicating there's no evidence of overfitting, which also indicates that model's ability to generalize well. But unexpectedly, decision tree actually performs the best with the lowest ASE and MAE for test set, with the lowest ASE for training set. So this might be due to the data set being less complex, which in this case, it is sufficient enough to use decision tree as best predictive model. So based on the result of time series analysis, the airline services and flight route based time series provided around 10 and 30 different time series respectively. So the flight route seems to have a higher similarity and lower variation, with the maximum similarity measured is only around 0.11. So this indicates the pricing consistency and less variation. But the airline services actually indicates a higher value and range, which is from around 0.27 to 0.89. But however, overall, the mean squared deviation is still below 1 in an unscaled normalization. So this indicates actually the relatively higher similarity and consistency in terms of pricing for both aspects. So this also proves the result of predictive model consists of low and consistent error between train and test set as well. However, this actually does not represent the real life scenario case, such as the seasonality variation. Thus, a longer time period should be included in the future approach. So in conclusion, the objective of this project is actually to analyze the flight booking data set via SEMA. And the sample, we chose random sampling to avoid biasness. And we explore this, in terms of explore, we skewed the distribution of price data and potential outliers based on price. So we analyze also using the association rule as well as sequence analysis to see the pattern of association within variables. So for the modification state, we impute the missing values of duration and log transformation of price column. And in terms of model assessment and future approach, the decision tree is the best model, while other models are able to generalize well as well. Time series analysis indicate the pricing consistency across time. And in future approach, we have to increase time frame of data set to add seasonality variation for better representation of real life scenario. That is all from us. Thank you.